A, B, C and D are 4 points on a circle. SBT is a straight line and it's a tangent to the circle. And angle ABD is 20 degrees. And we're told that the size of angle BAD and the size of angle BCD are in the ratio 3:1. We need to find the angle SBA, giving a reason for each stage of our working. And the size of the angle BAD and the size of the angle BCD is in the ratio 3:1. So that's this angle here and this angle here. Because that's really helpful, because if we look at the shape as a whole, we've got a quadrilateral here. And that quadrilateral is within the circle. So that means what we got is a cyclic quadrilateral. And one fact is the opposite angles in a cyclic quadrilateral add to 180 degrees. So this angle here and this angle here add to 180. Okay, so we've got 180 degrees in total, and we're sharing that in the ratio 3:1. So to do that, we're going to do 180 divided by, and there are 4 parts in total, so we've got 3 and 1, so add them together we get 4. 180 divided by 4, which is 45 degrees. So that's one part of the ratio. So from that, we can work out that actual size of the angles. So angle BAD is going to equal, so in the ratio there, we're looking at the 3 here. So it's going to be 3 multiplied by what we worked out for one part, which is 45 degrees, giving 135 degrees. Now let's do the same for the other angle, so BCD. So in the ratio, that's 1. So 1 multiplied by 45, giving us 45 degrees. And let's check to make sure these add up to 180, and they do. So this angle here, 135 degrees, and this angle here, 45 degrees. So now we've got more information to work with. We can work out this angle here. We know that angles in a triangle add to 180 degrees. So if we do 180 minus the 2 angles we already know, so 20 and 135, we get 25 degrees. So that means here, this angle is going to be 25 degrees. So now for the next part, I'm going to use the alternate segment theorem, which says the angle between a tangent and a chord is equal to the angle in the alternate segment. Now that's a bit confusing, so we're going to see how it applies here. I've got this triangle here, and we've also got a tangent. Now by the theorem, this angle, so going from the tangent to the triangle, is the same as the alternate angle. So down here, this one we worked out 45 degrees. So that angle there is 45 degrees because of the alternate segment theorem. Now I should probably make it clearer here that this 45 degrees refers to the whole of this angle here. But what I want to work out is the angle SBA. So just this bit of angle here. So this green bit is my goal. Now we've just worked out that the whole thing here is 45 degrees. And we know this bit is 20 degrees. So this green bit must be the difference. So for that we do 45 degrees. And we take away 20 degrees, leaving us with 25 degrees, which is the green bit there. So we get 1 mark for this bit of working down here and making sure we've given our reason. And we didn't actually need to do this step here, but if you did do it, you would get a mark for that. Or alternatively, we get 2 marks up here for getting the 45 degrees and giving a reason. We get a 4th mark up here for the correct answer of 25.